Day 75 Notes. Today's purpose: I will learn the parts of a volcano and how different types of volcanoes are made. Relevance: I will read about volcanic eruptions in the news. The state of Hawaii is made of several volcanoes, so for those reasons it's nice to know a little bit about them. Success: I'll be able to label a volcano with its parts and will be able to describe how the four types of volcanoes form. What is a volcano? A volcano is the vent and the volcanic material that builds up on the Earth's surface around the vent. Melted rock leaves the volcano through this vent, and then it piles up around it in various shapes. So in your diagram, we're going to first label the top being the ash cloud. It looks like smoke, but it's different kinds of material. It's actually little tiny bits of molten rock that, as they are thrown up into the air, cools down and forms this ash of various sizes. It can be flakes like snow, or it can come down as pebbles even, or even larger than that. Pieces that are as big as a baseball would be called volcanic bombs, for instance. But the ash cloud is the most famous kind of emission. And then below that we have the crater. The crater is the main opening that the material comes out of, and that is the top of the main vent. Main vent here. Main vent. And then we have side vents that might branch off of that in various locations. Here's another side vent off here, and a side vent there. The main vent goes up the middle. The top of the main vent is known as the crater. Different volcanoes have different kinds of structures making up their mountain size. In this one here we have layers of lava and ash. We have alternating layers: ash, lava, ash, lava. And at the bottom we have the magma chamber. That's a large pooled area of magma underneath the volcano. And sometimes that magma chamber can have so much pressure that it starts to bulge out the sides of the volcano. And that's how geologists know that it's about to erupt. Some vocabulary. The vent is the opening in which the magma flows to the Earth's surface. Remember that magma is melted rock below the ground. The crater is the funnel-shaped depression formed from the ash building up around the vent. This can also be described as being bowl-shaped. So don't just memorize funnel being the crater. It could also be bowl or other kind of similar words. And then the caldera is a top of a volcano that has caved in. Not all volcanoes have a caldera. There is a gigantically huge volcano in the area of Yellowstone. That's why Yellowstone has the geysers, because of the magma that's underground. And long, long ago, the crater of that giant volcano caved in, and we now have a caldera that is very, very wide. I think it's several miles wide. Types of volcanoes. A volcano is classified by its general shape and the type of eruptions that it has, and the type of plate boundary that it is near. The first kind that we're going to be looking at is called a cinder cone volcano. The shape of a cinder cone is moderately steep sides. It's the medium kind of volcano. It has a large crater around the vent. The eruptions that make up a cinder cone volcano are very explosive. They shoot melted rock very high into the air, and this cools in the air. Either comes down as ash, which again looks like smoke, or looks like snowflakes perhaps. Or it comes down in pebbles or even larger rocks called volcanic bombs. And all this stuff can pile up to make the sides of the volcano. And this is usually made by a convergent boundary with subduction. As one of the plates is pushed down into the earth, it causes melting, and that melted magma comes percolating up to make a volcano. A shield volcano is the second kind of volcano that we're going to be looking at. It has very gently sloping sides. It's called a shield volcano because if you laid a shield down on the ground, it would make the same kind of a shape as this volcano. It'd be much more wide than it is tall. It looks sort of like a pancake. The eruptions that make a shield volcano are very gentle, relatively quiet, smooth-flowing lava. There might be a little bit of explosive action, but generally it's smooth-flowing, no great plumes of ash coming out or things like that. People might be able to stand next to this and watch the lava flow, and it flows slowly enough that you can get out of the way if you need to. Some of the lava does flow rather rapidly like a river, but the general idea is that it's not being thrown up into the air. The plate boundary is going to be a divergent boundary. This is where the two plates are spreading apart. They are splitting. They are moving in opposite directions, making a big crack in the middle. These produce volcanoes with mild volcanic activity, and since the magma just oozes up between the moving plates, no major plumes of ash rise to the sky. And Iceland is this kind. A hotspot is an area in the middle of a plate. This is not at a boundary, but this is in the middle of a plate where magma works its way up to the Earth's surface with mild volcanic activity. Hotspots don't move, but the plate's creating a chain of volcanic islands. Let me say that again. Hotspots don't move, but the plate moves. And so therefore, as the plate moves over the hotspot, it creates a chain of volcanic islands. So here we have a plume that is a hotspot, and it makes a volcano right there. But the plate is going to end up moving this way. And so eventually the hotspot will be over another part of the crust, and a new volcano will sprout up. So these are a series of volcanoes that were made as the plate moves this way across this hot spot, this plume of magma that's rising up in the middle of the plate. Hawaii has a couple different names for the lava that's flowing there. They're kind of funny looking, funny sounding. Pahoehoe, I think is how you pronounce that first one. That's very thin, runny lava. And then a bit thicker. This makes more jagged rocks than the thin Pahoehoe. I might be pronouncing those wrong. Okay, stratovolcanoes are the steepest kind of volcano. They are made with very steep, jagged ridges. These are the tallest volcanoes, I believe, as well. The eruptions alternate between explosive and mild. So you have explosive ones that create lots of cinders, lots of ash and pebbles that come down, and then you'll have a flow of lava. And so this mix of lava and cinders is sort of like having wet sand at the beach. You can make a steeper, taller pile of sand if you alternate between piling on some sand and then some water, then some more sand, then some more water. If you do that, then you can make a tall, steep pile. If you just had dry sand, you can make a pile, but it's not going to be as steep because gravity pulls the sides down. A similar kind of a thing is happening with the cinder cone versus the composite or stratovolcano. A cinder cone is like trying to pile up dry sand. It's going to have a certain steepness, and that's as steep as it's going to get. The stratovolcano is like wet sand, where you have this mix of lava and cinders. It's like a mixture of water and sand. You can make it much steeper. Okay, I think I repeated myself enough there. The plate boundary is going to be, again, convergent with subduction, and they produce volcanoes with explosive volcanic activity since the subducted plate's magma has to push its way through the overlaying plate. Examples are what's called the Ring of Fire. This is a line of islands and volcanoes that go around the Pacific Ocean. About 2/3 of the active volcanoes in the world are located here, and that includes Mount St. Helens. It also includes Japan and the southern coast of Alaska. going down to Vancouver, Canada, and other islands in the southern Pacific. And that's the end of the video.